Ok, ciao a tutti, sono Calvin Zito. Io lavoro per Hewlett Packard Enterprise, ho lavorato in tecnologia per 33 anni, in HPE Storage per 25 anni. This is important personal information. Mi nonna è nata in Palermo e mi nonna nato a Corleone. So you all know Corleone, right? La familia, okay? So everybody's going to enjoy this presentation and lots of applause. Yeah, thank you. Perfect. Okay, we're off to a good start. So, like I said, I'm going to switch to English now because you've got about as much of the Italian that I can do without messing up too badly. I started in HP, like I said, about 33 years ago. I started as a field engineer. I moved to storage in 1990. A story that I'll just love to tell about the industry is when I started in storage, we made disk drives that were about the size of a dishwasher in your house. They were 125 megabytes, and they cost about $20,000. And those were the ones that had removable disks. So I've been around for a long time, long before there was RAID, and have seen a lot of change in the industry. So it's been fun and exciting, just in terms of how you can find me. I used to be known as HP Storage Guy. Of course, HP just went through a separation, and the company I work for now is Hewlett Packard Enterprise, and now I'm on Twitter as Calvin Zito. Okay. I'll just give you a couple things. This will be on the video, and this will be in the slides that you can get a hold of, but you can see where my blog is. We have a group on LinkedIn, so anybody who's a customer and you want to join the group or a partner, feel free. There's a URL for the storage group. You can find me on LinkedIn easy, and then again, there's my Twitter. One more housekeeping thing. There's a couple things that I can offer you guys if you want to get it. There's a software-defined block-based storage that works great with VMware. It's actually a product that we've had in the market for over 7 years. There's been over 1 million licenses shipped. It's very, very prevalent in the market, very mature product. That's Store Virtual VSA. There's a link where you can go get a free trial. That's a 1 terabyte trial. If you happen to be a vExpert or a partner and you want a bigger license, contact me. I can get you a 10 terabyte license. There's also another product that we won't talk about at all today. In fact, we're not really going to talk too much about either of these products, but there's a software-defined deduplication backup appliance that's also a VSA. That's the Store Once VSA. You can get it at the same URL. And again, there's my email address. We also have a 3-par simulator. So if there's anybody that wants to get the 3-par simulator and get some experience with playing around with 3-par, send me an email and I'll get you the simulator. Okay, so we need to move on to the topic. So the topic we're going to talk about is vVOLs. How many of you know a little bit about vVOLs? Okay, for all you guys that are raising your hand, come up. There's going to be some chocolates for you. For those of you, how many, and this is not to embarrass anybody, how many really don't know a lot about vVOLs and don't know why you might want to use it? Okay, everybody looks like they're pretty well informed, so that's good. So we probably won't spend a lot of time on some of this. So let me just talk a little bit about kind of the relationship with Hewlett Packard Enterprise and VMware and where we came from vVOLs. The collaboration actually started with 3-par before HP had acquired 3-par. So that started, pre-HP, which would have been before August 2001. Okay, I'm just going to have to use the keyboard. In 2011 at VMworld, there was a vVOLs preview, and HP was one of the 5 original design partners. In 2012, 3-par was selected as the exclusive fiber channel reference platform for the development of vVOLs. We had a demo that we showed at VMworld in October 2013, hands-on labs and videos that we've done that really kind of gone into a lot more detail. And then just, recently as it released, we were one of the few partners who actually had vVOLs supported on day one. So with HP 3PAR, we supported vVOLs on day one. So a strong, rich history there in terms of development of vVOLs and strong solution with vVOLs and 3PAR. So since you guys seem to be very well knowledgeable about vVOLs, I'm going to kind of go through this pretty quickly. Of course, you know, the issues that we know about with existing VMFS was that it was great in its time, but you know, it became a LUN-centric model, which had a lot of inefficiencies, created inefficiencies in storage, having to provision storage, pre-allocate it, over-provisioning resources, having siloed pools of storage, complex to manage, just a lot of issues that made storage more complex, and it required having a storage administrator and managing storage outside of the VMware domain instead of a VMware administrator really being able to manage storage. So here's a little bit of what virtual volumes then addresses. So it's more of a VM-centric model. I think everybody understands that. We can now more dynamically allocate storage. You only use what you need when you need it. There aren't really storage pools that you have to create ahead of time. It's a lot simpler to manage. It's going to move the management of storage really away from the storage administrator and into the hands of the VMware administrator. Space reclamation, I mean, we've talked a lot about T10 on map, and everybody knows about some of the issues we've had with that over the years. That's pretty automated. Not really a whole lot of anything you need to do with vVOLs to reclaim that space. You basically will now be using the vSphere management tools to do almost everything. Provisioning is really fast, and the array services are aligned down to the VM now. So now instead of doing things at a LUN level, you do it at a VM level. So this kind of summarizes, you know, what the goals were, and it's really about getting a more operationally efficient model of managing storage within a VM, so that we're looking at things at an application level instead of having to manage infrastructure. So there's really three main things that it does. It's about simplifying management because we're now automating a lot of the tasks. We're eliminating a lot of the dependencies that we've had in the past to be able to provision storage. We're having more fine-grained control of the storage. We don't have to over-allocate. We don't have to throw a bunch of storage into a LUN and try and manage all the VMs in a LUN. Instead, now we have that more granular control, which gives us a lot better SLAs. And Duncan talked about that this morning with vSAN. In fact, one of the points we'll make here in a little bit is that, you know, all the features that we're talking about with vSAN, you basically get those delivered through vVOLs, at least in terms of how it's managed. Obviously, a lot of the array-specific stuff still happens from the array, but a lot of the things that Duncan talked about in terms of being able to set policies and things, we'll see that here in a little bit. And then really improved efficiency because now we can consume storage resources as we need them. So I'll run through this fast. This is really where we're kind of moving things so that we can take advantage of features of an array and get the array doing the work. And let's, you know, not have vCenter and ESXi doing the work of things like creating snapshots or using thin provisioning. So that's one of the big things that we're doing with vVOLs is we're offloading a lot of that function from vSphere and the hosts and putting that onto the storage. And at the end of the day, as you see over here on the right, what we're doing is we're eliminating a lot of the common tasks for the storage admins that storage admins had to do in the past, and we're making the management occur on the left side, which is over on the vSphere side. So I'm going to quickly talk about the vVOLs architecture. Again, I want to be careful of not repeating things that maybe you already know, but I'm going to do this quickly, and then what we're going to do is we're going to get into a demo. How many of you guys have actually seen a demo to the point where you really understand how vVOLs works? Okay, very few hands, so that's good. So I think the demo will be useful. Okay, so here's kind of an overview of what vVOLs design looks like and the core components of a virtual volume. So first is this thing called a protocol endpoint. A protocol endpoint is basically a connection that we make between the hosts and the storage array. It's a proxy I/O path. It's kind of independent of any protocol, and it's as it says in the bullet there, it's the logical path, or it's the data path between a host to the VMs and the respective vVOLs on the storage array. VASA provider, this is something that was introduced, what was it, 5.5, Duncan, or was it 5.0 when VASA 1.0 came out? Wasn't a lot of functionality in that, but it was laying the groundwork for what we now have with vVOLs. So this is basically the software component that really mediates the out-of-band communication that happens between the vVOLs and the traffic between the vCenter server, the SXI hosts, and the storage array. In the example that we'll show here with 3PAR, and I won't deal with this in too much detail, but as an array vendor, you have a choice of where you want to put that VASA provider. On 3PAR, we actually put that VASA provider. It runs on the controller. I'm not sure if there's too many other array vendors that do that. I think a lot of the other array vendors are running it as a VM that runs in the cluster. For 3PAR, we run that VASA provider on the controller. Personally, we think there's some advantages to that, but that's something if you guys want to talk about offline, we sure can. Then there's the storage container. This actually is just it's a logical pool of capacity. It doesn't actually contain any storage. You're not pre-allocating storage to it. It's basically just a raw pool of capacity that becomes the way that we logically group the vVOLs and present those to vCenter. Then there's the actual virtual volumes, and these are kind of where we kind of break the model of what we had with VMFS. This is where now we're going to get down to the level of each VM will have a number of different vVOLs that get created and have different functions, and I'll talk about what those different types of vVOLs are here in a second. And then there's the storage profiles, and this is this is where we take the capabilities of an array and make those available to vCenter, so vCenter knows exactly what can I do with this array, like what kind of features does it have. What kind of a disk drives is it using, so we can set up policies and, for example, set up a gold, silver tiers of storage, whether or not we're using deduplication or not, and just kind of the features of the array that get defined and then exposed to vCenter. So we're going to meet the vVOLs. So this is the files that get created now. That you'll see as we go through this and as I show you the demo. First is a configuration file comparing it to VMFS. This is like a .vmx. This is the config file that basically contains the VM config data and the metadata that we use to manage it. It also contains the VM lock and log files. It always gets provisioned thin, has a maximum size of 4 gigabytes, and there's always one per VM. Data file, this is similar to what we know of as a VMDK. It's a raw virtual disk. We also create these when we create a snapshot of a virtual machine. So we'll see that here in a few seconds. It normally is provision thin, but if you have a reason that you want it thick, you can certainly provision it thick. But again, I think most people will provision these thin and take advantage of an array's native capabilities to do thin provisioning. Maximum size, like a VM, is going to be 64 terabytes, and there's going to be one for each VM disk, and then there's going to be one for every snapshot. Swap file, this is similar to the VSWP. This is kind of the file for the memory overcommit, so this is where we kind of swap things in and out of memory. So this gets created as a separate file, and as such, it can be saved and it gets created when you I think it's actually when it gets created is when you power on a VM. So I think we'll see that here in a second. It's provisioned full because you don't want this thing to be slow. It needs to be extremely fast because we're using this as a place to move memory when we have overcommitted memory. Maximum size is 4 terabytes, and there's always one for each virtual machine. And then the last one is a memory file, which is similar to the .vmss in the VMSN file. These store memory state for suspended VMs and snapshots. It's always provisioned full, has a maximum of 4 terabytes, and there's one for each VM suspended or each snapshot. Okay, so I think we're almost to the point where we can look at the demo, but I want to cover one other thing before we do, and that is kind of talk about policy-based management. So again, Duncan hit this before. People are a little afraid of the big names, and it's SPBM. This really is important, and maybe one of the really highlights of being able to use vVOLs. And so it uses the same SPBM engine that I was referring to before that vSAN uses. It allows VMs to be provisioned onto storage. that best suits application requirements. So you basically would go through and you'd create policies that define what a tier of storage might look like. Storage policies are built from the array capability. So if you've got an array that, for example, doesn't support SSD, you're clearly not going to be able to build a gold policy with SSD. Or if you don't support deduplication, you're not going to be able to build a policy that includes deduplication. So it really just takes the capabilities of the array that are exposed to the VASA provider, and it makes that available. Yeah, so let's keep moving from there, because I think what I want to really do is get to the demo here. So I'm going to minimize the presentation. We're going to look at this demo. So this is a recorded demo. Thought I had it open here, but let me get it going. I didn't have a way to do a live demo, and I'm not brave enough to try that. So this is a recorded demo, and I'm going to talk you through it here. Get it full screen. Okay, so what we're going to look at in this demo is we're looking at starting at the 3-par CLI. So this is the 3-par CLI. We're going to be able to see a lot of things that maybe you necessarily wouldn't look at as a VM administrator, but I think looking at this will be helpful because it'll help expose you to what the underlying things are happening as we start creating volumes or start creating VMs and then start doing snapshots and delete snapshots and things like that. Okay, so here we go. The first thing that I'm going to do in the demo is that I want to make sure that the host that I'm using is using the right persona. 3-par uses this concept of persona, and the VMware persona that we need to use is a persona number 11. So I ran the command. You can see that it says that it's VMware persona. Next thing I want to do is I want to make sure that the VASA provider has been enabled, so I'm going to run the VASA command, show VASA, and you can see it says that it's disabled, so it's pretty easy. What I need to do to run it is just run the start VASA command, and let's just confirm that the VASA provider actually started, and you can see in the small print, it's going to be really small, so for those of you that want to really see the details of this that maybe aren't going to be easy to see in the demos, this is demos also online on YouTube. So there you can see it says that it's actually now enabled. So next thing I'm going to do here is I'm going to switch to the host, and I'm going to run a command that I'm not even going to try and tell you what it is. It's a pretty long command, but I'm going to run this because I want to see where my protocol endpoint is. And what this allows me to do is, first of all, I can see my worldwide name for my 3-par. I'm going to go back to the 3-par CLI, and I'm going to take that worldwide name, and first of all, I can see that it's there. Now you can see where I want to look right there. I'm going to pause it for a second. You can see I'm looking to see if the protocol endpoint is actually turned on. You can see that it says true. So now I've confirmed that I actually have a protocol endpoint already set up. Okay, so now I'm going to go to vCenter, web client. We're going to define a new storage provider, which basically is going to be our VASA provider. I'm going to use that URL that we had here for the VASA provider URL. I'm going to put it in. I'm going to define a user's name and password, click OK, and now it's going to go ahead and create that storage container. Well, actually, I'm sorry. That's where we create the provider. So now what I need to do is create the storage container. Creating a storage container is a lot like creating a data store. So I'm going to go up here on the left-hand side. I'm going to click on data stores, and I'm going to then go through and you'll see as I start to do this that there's a new box or a new selection that'll pop up that actually says, is this a vVOL? So there we go. I'm starting the process to create the new data store, and there you can see, I'm going to pause it real quick, and you can see there's the option on the bottom that says vVOLs. So here's when 6.0 or higher, there's an option to select that, I'm going to go ahead and create a vVOL here. And this is actually the storage container for the vVOLs. Okay, from there I'm going to keep going. We're going to give this a name, give it a name so that we know it's our storage container. There's a name that is identified from the 3-par side. This actually is a name that automatically gets provided. It comes from a 3-par serial number so that we know what we're dealing with here. We'll click next. We're next going to select the host, click next, and finish. And now we'll be able to see that we've got our storage container. I'm going to go to host now. I'm going to click on the Manage tab, Storage and Protocol, and we'll be able to see that there's the storage endpoint. And one thing I want to point out is with multipathing, this is kind of an important point with specifically 3PAR, is that with multipathing we have to set up round robin, and the reason for that is because it's an active array, and that's just basically what VMware wants for an active array. You have to set up multipathing, round robin. Okay, so next we're going to look at storage policies, and this is where I've talked about we take the 3PAR capabilities and create profiles that will come into play. So what I'm going to do is I'm going to go into VMware Storage Policies. We're going to click on the policy icon, and now we want to create policies to match our CPGs. CPGs is a I don't want to spend time explaining it, but it's a 3PAR kind of concept where we create physical volumes or physical units of disks that we collect together and then create logical groupings of arrays, so of disk. So things that we might create a CPG of are a RAID level. We want to create a RAID 1 CPG, or we want to create a SSD tier and use a kind of disk to do it. So hopefully if you don't understand that concept of CPG and this becomes a little confusing, hopefully you'll see what we're doing here as we go along. Okay, so now I'm going to set up my storage policy. This is going to be my gold tier. This happens to actually be a fiber channel, or we call it fast class, not fiber channel. It's a fast class disk, so it's a 15K disk. We're going to configure this as RAID 1. You can see that I can pick that I'm going to use thin provisioning. I'm going to set up the snapshots here. And for my snapshots, I don't necessarily need to use RAID 1. So for my snapshots, you're going to see I use RAID 5 for snapshots for this policy tier. And we're going to set up a few other things that are capabilities within 3PAR. I'm going to set up thin persistence, which is a feature that's unique to 3PAR that we expose to vCenter. I'm not going to allow deduplication because I'm using spinning disks in this example, so I'm not going to turn on deduplication for these. That's a point to make, that with 3PAR you can decide whether or not you're going to turn deduplication on or off. Okay, so we'll let it keep going from here. So now what I need to do is just make sure that this policy fits within my virtual volume. You can see it says it's compatible, so it's basically telling me that this is a policy that I can use, and now it's going to go off and create the policy, and there you can see I now have a storage policy. And I'm going to speed through this fast. I'm going to do a silver policy. This is basically going to be a RAID 5 policy using slower disks. Okay, so now I've created two policies. There's a 3PAR gold policy. There's a 3PAR silver policy. Now would be a good time probably to create a VM. So let's look at what happens when we create a VM. So I'm going to give my VM a name. For this one, I'm going to call it VM1. I'm going to pick using my silver policy, so I'm going to create this VM as using that silver policy that we just created. So this is basically like I said, it's using RAID 5 and a little bit slower disk, so it's not the fastest tier storage that we've got in this array. It's a little bit of a slower tier. I'm going to pick Linux, and you can see the Red Hat OS is what I'm going to use for this VM. Got my hardware choices that I'm just going to leave as is, and I'll get one last review, click Finish, and we're now going to create that virtual machine. We're going to switch back to the 3PAR CLI, and I want to show you now what you actually see now that this virtual machine has been created. There's a new command that we have with 3PAR. It's called show vVOL VM. So I'm going to run that command, and you'll see now what's been created in the back end with this virtual with the vVOLs. So there you can see after I've run that command, there are two files that have effectively been created, or two vVOLs that have been created. One is that config file that we talked about before, so that's what has the metadata. And then there's also the data file that every VM has created for it. So this is essentially the the VMDK that we saw in under VMFS. So let's keep going from here. And there you can see the two files that are being highlighted. So right now the VM is turned off. I want to show you that it shows that it's bound. What just takes us a couple seconds for a 3PAR to see that VM has been created. And in a second here, when I run that command again, the show virtual volume vVOL VM, you're going to see that it now says it's unbound. So it's ready to go. We're going to go back to vCenter, and it's right now powered off. We'll go back and just look one more time, and I've powered it on, and now you can see I now have that swap file. So I mentioned once you power a vVOL on, or once you power a VM on, you'll see that this third vVOL gets created, the swap file. So let's just kind of review. We've created the VM. Before we turn it on, we've got the config file, the data file, and then once we turn the VM on, we get this other file that gets created, the swap file. And all of these, just get created automatically. So these two virtual volumes that got created initially, they were all done automatically. Nothing that I've had to do here. I'm just showing you this detail, not to confuse you, but just so that you can see, what's happening in the back end. One thing I want to point out here is I ran another command that it went kind of screaming past, but I went back a little bit so you can see it. So at the bottom of the screen, I ran a command to show the CPGs allocated. So if you look, and right where I'm pointing the arrow, you can see that it says that these are fast class. That's the FC, the RAID 5, and you can see that the snapshots will also use the RAID 5 as if I create snapshots from this VM. Okay, so now we're going to go back in, and why don't we go ahead and create a snapshot? So we'll go in and create a snapshot, give it a name. Actually, I'm sorry, what I'm going to do first is I'm going to create a new virtual volume, and I'm going to create this virtual volume using that gold policy. So now you can see that virtual volume has been created, or that VM has been created. I've got two VMs now. I've got the VM Gold, I've got the VM1, and as you look at the virtual volumes that have been created, you can tell by the name, the first two say VM Gold in the name, so now I have that config file and that data file, and then for the VM1 that's been powered on, I have the three files that have been created. So again, we'll look at what the underlying CPGs are, and you can see with that VM that we just created that I had the gold policy, so I had the RAID 1 there, and then I had for the snapshots, it was going to use the RAID 5 for the snapshots for that gold policy VM that I just created. I'm going to go back to vCenter. I'm going to go ahead and create another snapshot of the first VM that we created, so I'm creating another snapshot. This is snapshot number 2 of that silver policy VM that I created. You can start to get the flow of what's going to happen here. We'll go back to the client or the GUI, and we're going to look at now what's been created on the back end from a virtual volume standpoint. So there's that show vVOL command, and now you can see I've got five separate virtual volumes that have been created. You can see by the names. Well, I can see by the names. Hopefully, you can see these a little bit. That the bottom 4 are for that first VM we created using the silver policy. So now you can see that there's 2 data files because we've created that snapshot. And then I've got the original config and the original swap file. So we'll let that go forward from there. So I'm going to go back to the web client. I'm going to now take a snapshot, another snapshot of that virtual machine. We'll go back and look and see what's been created. You can see there I've got, under VM Gold, there's 2, and under the VM1, there's 5. And now you can see all of the the files that now have been created. So now I've got 1, 2, 3, 4, 5 files that have been created for that VM1. Again, that's the original silver policy we did. Now you see that there's 3 data files. So I've got 2 snapshots, the original virtual machine, the one for the original virtual machine we created. Almost to the end here. Hopefully, I'm hoping that you guys find this useful to see what's going on in the back end. Again, don't want to scare you with this stuff. As a VM administrator, you probably are never going to touch this. That's the whole point of vVOLs, is to make this a lot simpler. So as a storage administrator, you probably are not going to be going back to the 3-par CLI to see the kind of the details going on. And especially if you got a bunch of VMs that you've configured, the number of VMs you're going to see with, you run 20 VMs and you're taking 10 snapshots, you're going to see a ton of files. So it's really not intended to be something that you do on a daily basis, but it's there as a tool that if you wanted to go back and see it, you can. Okay, so we're going to power that VM1 off. We'll see what happens as we power that off. First thing I would expect to happen is that swap file goes off, and it did. That second snapshot, I didn't say that when I did it, but that second snapshot I did include the memory. So now you see that memory took a little bit longer to create. It's actually there, but since I just turned that VM off, I think in a second here you're going to see that memory file go away too. So what we've seen is the swap file gets turned off because I shut that VM off, so the swap file goes away, and in a second here you'll see that memory file go away as well. Okay, now why don't we just go ahead and delete that virtual volume. So now we're just going to get rid of that VM. We're going to get rid of VM1, and then we'll go back into the CLI, and you can see that it took a second because that config file hung around for a second for VM1, but after I ran that a second time, everything's now cleaned up. There's nothing left from that VM1. The good news is because I've done it this way, and well, just not because I've done it, because VMware designed it this way, the virtual volume the space has now been returned. You don't have to do the unmap anymore. Just because of the insight that we have down at a granular level, there's now no need to try and recover that space. It's automatically been returned to the pool. So just to finish it out, I'm going to go ahead and delete this last one. And we'll go back and see from the... And now you can see there is nothing left. So we went through this whole process of creating a VM, creating snapshots, deleting some snapshots, and now we've deleted all the VMs, and now all the virtual volumes that we created through that process are gone. Okay, so that's what I wanted to show you from the demo standpoint. I've got about 10 minutes left, so let me cover just a couple things here, and we'll wrap up and maybe take some questions. Okay, so here's just kind of a high-level comparison, and really I'll leave this to you guys for on the video if you want to pause it on the video, or for those of you that get the slides. This is a good reference to see what kind of things you can do with vVOLs and what we could do with VMFS that maybe just haven't caught up yet. So a couple of the important ones I'll pull out is if replication is important to you, probably should be waiting and not going to vVOLs yet because replication isn't supported yet. I can't tell you when that's going to be supported. Duncan left, we maybe could ask him, but I don't know exactly the timing for when replication will be supported. Given replication isn't supported, that means SRM and VMSC is not supported. There's no support for direct backup to SANs. The support for vRealize Operations Manager, that's going to be a future. But you can then see on the other side of what kind of things VMFS doesn't support with that we do get with vVOLs. So vVOLs, I would definitely say is a 1.0 product. There's a lot of promise, and at some point, I'm guessing that we'll see a lot of almost all of our VMs are going to end up going this direction. There's a couple cases where maybe people aren't going to want to use vVOLs, but we'll cover that maybe sometime in the future instead of here now. And again, this slide's really busy. Again, it's just going to be there as a reference. Kind of a listing of things that, products that don't support vVOLs today, features that don't support vVOLs today, and I've got a list of the vendors. The list of vendors, I'll put a disclaimer up. This is actually probably 2 or 3 weeks old, so if something's changed, you'd have to check the VMware hardware compatibility guide to see who else maybe has got vVOL support at this point. But that was the list as of about 3 or 4 weeks ago. Okay, so a couple last things I want to hit. I want to talk a little bit about, we've talked about 3PAR. You've seen 3PAR. With just the last few minutes left, I want to, for those of you that maybe don't really understand 3PARs, maybe spend 10 minutes and just talk about 3PAR and how 3PAR is really ideal for a VMware environment. So, when you see these eyes in the dark, they look the same. They all look like they're efficient, autonomic, and resilient, and everybody's out there claiming that they're that, but when you actually see these things in the light, cats maybe look a little bit different. You can guess which one I would say is 3PAR. I've already told you. And, well, we'll just leave that out there. So there's a number of things that I think that make 3PAR really interesting. And a lot of these, I could just probably do sessions on each of these. We don't have that time. So let me just kind of hit some of the highlights. Federation technologies. We now have technology with the latest generation of the 3PAR ASIC that you can put 4 3PARs in a federation, and you actually seamlessly, with one click, move data between 3PARs. So no additional software needed, no hardware. You don't have to put some kind of virtualization device in between. You basically can create a federation of up to 4 3PARs and just move data around between those 3PARs. So if you wanted to have a flash tier, use a slower tier, or if you wanted to balance workloads, you could basically move data around with one click with almost no effect that the users would know you're even doing it. Flash optimization, I think this is an interesting one. I think 3PAR, we announced Flash about 2 years ago. I think there were a lot of rolling of the eyes from the startup vendors that said, no, you can't be Flash because you didn't design from the bottom up for Flash. Fact is 3PAR was designed from the bottom up to serve IOs as fast as it could and to protect IOs. And frankly, I think it shows. There was just some SPC2 data that we released last week. 3PAR is now the world fastest SPC2 benchmark results based on using a 3PAR all-flash array. So from a speed standpoint, it's at the top of the class in terms of performance. And again, I'm feeling pretty good about all that, because when we first launched 3PAR, I had a lot of people that told me, you guys aren't all flash. You didn't design from the bottom up. You didn't start from flash. Guess what? We're now the number 2 all-flash vendor in the market sizing from IDC. So we've gone from number 10 in 2014 to now 3PAR is actually the number 2 all-flash array in the industry. Optimization and compaction technologies. One of the things that I think a lot of the flash vendors deal with is they want to throw out the numbers of how much I'm going to dedupe, and we're all proud of our dedupe numbers. Let me ask a question, and don't be afraid to answer. There's chocolate in it, so I will throw chocolate out to anybody that wants to answer this. What's the percentage difference from somebody that says they have 4-to-1 deduplication compared to somebody that says they have 2-to-1? How much more space do they get? 4-to-1, 2-to-1. Simple math, right? Anybody want to guess? What is it? You're close. 4-to-1 to 2-to-1, if you do line up the math, it sounds like it's 100% better, doesn't it? It's not. You go from 2-to-1 to 3-to-1, and that's 25% difference. So 2-to-1 to 3-to-1, you've basically gotten 25% better. When you go from 3-to-1 to 4-to-1, it's about another 8%. You take the 2 together, it's 25%. So I would actually say that you probably should ignore a lot of the clatter and the noise you hear about deduplication and compaction. What you really need to look at is what's the efficiency of the array. At the end of the day, what you're trying to do with all flash is when you put data on that thing, what's your capacity efficiency? Dedupe ratios, you want to try and calculate thin provisioning. I mean, that's all stuff you need to kind of understand to kind of evaluate what it's going to look like. But at the end of the day, it's about the capacity efficiency that you get once you put data on that device. So I think as Vaughn did, I would caution you to be very careful about just taking a deduplication ratio and thinking somehow that's going to be the magic number that's going to tell you what it is you're going to get out of that array. 3PAR today does native block, always has. It now actually has native file access as well. So that was added about a year ago. I don't know if you knew that. So it really is a converged technology from that standpoint. Thin technologies, I think 3PAR was the leader in that. I think it was what it was known for, and it's still some of the best, if not the best, thin technologies out there. And this last one, this mesh active architecture. I think this is really important. This, again, seems to be another point that I see a lot of the startups talking about, at least some of the competitive ones, and they say, you know what, 3PAR is using an ASIC, and doesn't that slow things down in terms of development? Well, here's what I tell you. That 3PAR ASIC is some special sauce. 3PAR is a very different architecture from the standard disk arrays that are out there. It's very different from the 2-controller arrays. It's even more different when you talk about it scaling out to 8 controllers, because that's what 3PAR can do. Basically what those ASICs do is it creates a mesh active backend. It connects all the controllers together, so it's basically a shared everything kind of architecture. So when you want to do an I/O that comes in through one of the controllers, and it can service that I/O to any of the disks that are in the back end, doesn't have to route traffic through a controller and say, hey, this LUN's owned by this controller, so we have to serve it from that. You can write to any disk from any controller. It's really kind of again, it was an architecture that was built to perform at its best, independent of what the storage was that it's going to be connected to. And that's frankly why it's doing so well from a performance standpoint, with very low latency. The latest high-end 3PAR array, we're getting down below 0.3 milliseconds in latency, over 3 million IOPS, kind of the max, probably not a realistic number that anybody should kind of count on, but when you try and make that thing scream as fast as it can, we're getting about 3 million IOPS out of a 3PAR at under 0.7 milliseconds of latency. So it really is a very different architecture. And there's a lot of things that the ASIC do. I think I'm down to about 2 minutes, so I'm not going to try and cover the ASIC, but again, one of the things I keep hearing come up is, oh, well, the ASIC slows things down, or slows development down. It doesn't. We were able to get hardware-based deduplication on the ASIC. That came about 1.5 years ago. We now have a new ASIC. There's more features that are going to come with that. There's a few things that I'd say the one thing glaring from 3PAR at this point is that it doesn't have compression. I think I could pretty much say it will. I can't tell you when, but it's coming, and it's going to get even better from a price standpoint. There's a lot of other efficiency things that 3PAR does. One thing I'll call out is like the SSDs that we use. We're able to get about 20% more capacity out of the SSDs everybody else is using, because we actually return that space, and we actually use it as usable space where, because of the way 3PAR stripes data across everything. Okay, so I'm happy to, I'll be around for the rest of the day. I'll be around till, what are we here, till 6 o'clock? And if anybody has any questions, I'll be happy to answer them. Again, if you want to get any of those free software-defined solutions, or if you want to get the 3PAR simulator, feel free to reach out to me, and I'll be happy to give you that. So thanks a lot. Thanks for having me.